Alright, so why am I showing with that previous picture? Well, now I'm showing something called net filtration pressure. Yeah, is that point only reached in the capillaries? Ooh, that's a good question. So the capillaries is where you would see that kind of balance right there, but would that happen in any other vessel? Well, the thing is that we don't really have as much hydrostatic. Thing is that with the other vessels, they have a thicker and thicker wall. You can have movement of fluid, but the thing is that because of that, those thick walls with the tunica intima, media, and externa, you're not going to have the similar levels of fluid exchange as you would with capillaries. But in the case of pathologies, that could affect that. But I think that's a little advanced. What I'm showing, okay, so back to our lecture. So what we have here is our net filtration pressure. So basically, you're determining which wins out. Is it the forces moving water from the inside towards the outside, or the forces moving water from the outside toward the inside of a vessel? So this is what we call our net filtration pressure, and for our class, this is the formula we'll use. Net filtration pressure is CHP minus BCOP, so capillary hydrostatic pressure minus blood colloid osmotic pressure. So again, this is one, and there's other pressures. So there is interstitial fluid hydrostatic pressure and interstitial fluid colloid osmotic pressure. But in healthy individuals, like, do you have a heart within each of your tissues forcing water back into and pumping and forcing water back into your blood vessels? You don't quite have that. So there is water there, there is hydrostatic pressure in your interstitial fluid, but so small it's practically zero for all intents and purposes. Same with interstitial fluid colloid osmotic pressure. Compared to all the albumins and proteins in the serum of your blood, you don't really have that many large proteins that contribute to oncotic pressure inside your interstitial fluid, so this is why you don't see these in the equation. For healthy individuals, they're practically zero. So again, CHP is capillary hydrostatic pressure, BCOP is blood colloid osmotic pressure. Now, how do we calculate that? Well, we know our CHP at different sides of the capillary. So what do? You just do simple subtraction. So net filtration pressure is just capillary hydrostatic pressure minus BCOP. So let's do this at each point. Now, again, this is our formula. CHP minus BCOP is NFP. So here at the arterial side, we have that relatively high capillary hydrostatic pressure, 35 millimeters mercury, and then we're going to subtract the blood colloid osmotic pressure, so around 25 right here. What's 35 minus 25? That is 10, right? Now, what if we're going over here where they're equal? Well, when CHP equals BCOP, what is a number subtracted by itself? It's 0, right? So what we have here, net filtration pressure is 0. And over here on the venial side, remember that capillary hydrostatic pressure drops off as you go from arterial to venial. And then BCOP is still going to be the same. It's still going to be negative 25. But now capillary hydrostatic pressure is less. So 18 minus 25. When you subtract a bigger number from a smaller number, yeah, it ends up with a negative number, right? So 18 minus 25 is negative 7. And that sign is actually very important. So what we have here, going from arterial to venial side, is that we have a positive net filtration pressure going from artery to on the arterial side. So again, and this is another way to think of how to know which way net filtration pressure goes. So again, filtration is movement in terms of filtration in terms of the cardiovascular system is movement from the inside of a vessel toward the outside of a vessel, right? So what we have here, if you have a positive net filtration pressure, it's moving from the inside towards the outside. Whereas if they're balanced, you still have movement, but in terms of like overall movement, it's going to stay relatively the same in terms of the volume of fluid when CHP equals BCOP. And on the venial side, now with a negative net filtration pressure, we're going to bring water back into the vessel. And this is basically me breaking down this image from your OpenStax textbook. So again, that's why I kind of like using that Martini version, because it has different parts. It's a little overwhelming at first, but if you're breaking part into many parts, it's actually more accessible. Okay, so net filtration pressure. So when you have a positive net filtration pressure, like we had toward the arterial side, that is overall movement of a fluid out of a vessel. Remember, filtration refers to, in the cardiovascular system, refers from a movement of fluid from the inside of a vessel toward the outside. So when you have positive net filtration pressure, it's moving from the inside towards the outside. When it's zero, there's no net change. Why? Because now we have CHP equal to BCOP. Yep. And net filtration pressure is less than zero. If it's negative, then you have overall movement of fluid into a vessels. And can these values be different depending on the individual? Yes, because again, we don't all have the same blood pressure. But for this class, I think it's good to start off with some sort of reference. So do I want you to memorize, like, it's 35 at the arterial side and 18 on the venial side? I don't think that's really useful in the long term, but you should know, yes, CHP does drop off from arterial to venial side, and BCOP stays relatively the same regardless of the pressure. So what I want you to know is how to calculate net filtration pressure. If I give you CHP and BCOP, can you calculate the net filtration pressure? Can you calculate whether you're going to have overall movement of fluid out of a vessel, or if you have overall movement back into a vessel? Will it filtrate or will it reabsorb? Yeah, so some of you, and so currently I think the split for the math questions is 80, a little over 80 in favor of multiple choice but no calculator. So if you're looking at this math and you're like, oh, I want to change my answer, you can edit the form and change your response. Okay. So filtration, again, NFP is filtration pressure is greater than zero. Reabsorption is NFP negative.